Hi students, in this video I am going to do problems from exercise 3a. Then I will be talking about equation of a tangent and normal to the parabola y square equal to 4ax. Okay. Here is the problem 6 of section 1 of exercise 3a. Find the equation of the parabola whose focus is point 3, 5 and vertex is point 1, 3. First, let me locate this focus and vertex. Here is the focus 3, 5. So this is the focus yes. And the vertex is point 1, 3. So this is the vertex. Let me call it A. Okay. And we know that line passing through this focus and vertex going to be the axis of the parabola. As you can see, this axis is neither parallel to x-axis nor parallel to y-axis. So, the parabola equation that we are going to get will be a general equation of the parabola. Okay, and we can write down general equation of the parabola if you know the focus and directrix. Here we know the focus, but we don't know the directrix. First, let us find out the directrix. We know that directrix will be the line perpendicular to axis and meeting axis at a point Z, so that vertex will be midpoint of this Z and focus S. Okay, so Z is a point, so that midpoint of Z and S should be the vertex A. Here we know A is given 1, 3 and the focus is given 3, 5. Now, since we know this A and S, we should be able to find out this Z. Let's say for a moment H, K. First, let us find out this H, K. Here, midpoint of Z and S is A. So, H plus 3 by 2 and K plus 5 by 2 should be equal to A, that is 1, 3. That means H plus 3 must be equal to 2, that implies H equal to minus 1 and K plus 5 must be equal to 6, that implies K equal to 1. So this point H comma K equal to minus 1 comma 1. Okay. Now I got a point on the directrix. If I know the slope of the directrix, then I can write down equation of the directrix. What I know here, the directrix is perpendicular to the axis. What is the slope of the axis? First of all, it is a line passing through 1, 3 and 3, 5. The slope of this line should be 5 minus 3 by 3 minus 1. So that's going to be 1. Okay. So the slope of directrix must be equal to what? Minus 1 by slope of the axis, that is 1. So we have minus 1. So now the directrix equation going to be what? So the directrix equation is the line passing through Z, which is minus 1 comma 1 and having the slope minus 1. So it should be y minus 1 times m. What is m here? Minus 1 times x plus 1. Okay. This is the line passing through minus 1 and 1 and having the slope minus 1. So this should give you y minus 1 equal to minus x minus 1. So we have x plus y equal to 0. Okay. So this line, directrix line is what? X plus y equal to 0. Okay. Now we got a focus yes, alpha beta equal to what? 3, 5 and the directrix Lx plus my plus n equal to 0 is what? X plus y equal to 0. And we know the general equation of the parabola in terms of the focus alpha beta and directrix Lx plus my plus n equal 0 is following: x minus alpha whole square plus y minus beta whole square equal to Lx plus my plus n whole square by L square plus m square. Here alpha equal to 3, beta equal to 5 and L equal to 1, m equal to 1, n equal to 0. Okay, so it's going to be x minus 3 whole square plus y minus 5 whole square equal to x plus y whole square by 1 square plus 1 square. So if I cross multiply, I will have 2 times x square plus 9 minus 6x y square plus 25 minus 10y equal to x square plus y square plus, if I write this x square plus y square plus 2x left side, then I will have x square plus y square minus 2xy minus 12x minus 20y, 34 times 2, that will be 68 equal to 0. Okay, so this is the general equation of the parabola whose focus is 3, 5 and vertex is 0.1, 3. Fine. So now I can write down equation of the parabola is going to be y minus 3 by 2 whole square equal to minus 4 times 1 by 4 times x minus of minus 11 by 4. It's going to be x plus 11 by 4. Okay, so this gets simplified to 2y minus 3 whole square equal to minus 4x minus 11. Okay, I can write minus of 4x plus 11. Okay, so this is the red parabola which is open left side. Okay, fine. Okay, so the equation of the so we got two answers here. So this blue parabola equation is 2y minus 3 whole square equal to 4x plus 13. Okay, and this red parabola equation is this red parabola equation is 2y minus 3 whole square equal to minus 4x minus 11. Okay, okay, fine. Next, problem 7 from the section 1 of the exercise 3a. Find the equation of the parabola whose lattice rectum is the line segment joining the points minus 3, 2 and minus 3, 1. Let me call this one L, this one L dash. Okay, let me locate this L dash here. So minus 3, 2, this is the L, minus 3, 1, this is the L dash. Okay, so L is minus 3, 2, L dash is minus 3, 1. Okay, so this is the lattice rectum. Okay, fine. And we know that the midpoint of this lattice rectum L dash going to be focus. So focus is going to be obviously minus 3, 3 by 2, which is the midpoint of L dash. And we also know that axis of the parabola will be passing through the focus S and perpendicular to the lattice rectum. So the axis of the parabola will be passing through S, okay, and perpendicular to the lattice rectum L dash. As you can see, this axis is parallel to x-axis whose equation is y equal to 3 by 2. Fine. So we are going to get the equation of the parabola whose axis is parallel to x-axis. Again, there are two cases here. Our parabola might open to right side or left side. So one case is our parabola could be looking something like this, open right, or it may be open left like this. Okay, fine. So in this case, the equation of the parabola will be in this form: y minus k whole square equal to 4a times x minus h. In this case, the equation of the parabola will be in this form: y minus k whole square equal to minus 4a times x minus h. Okay, here h comma k, in this case this is going to be the vertex. Okay, h comma k. In this case, in the blue parabola case, the vertex h comma k going to be here, somewhere here. Okay, so here we need to figure out AHK. Okay, first let me find out the equation of the parabola which is open right side. Okay, so first we have to figure out A. What we know here, the length of the lattice rectum, length of lattice rectum, L dash equal to 4A. But which is actually what L dash length is, as you can see, that is 1. So 4A equal to 1, that implies A equal to 1 by 4. So we got A equal to 1 by 4. Now we have to figure out H and K in the blue parabola case. Okay, so if A is H comma K, then S must be equal to, if vertex A is H comma K, then S must be equal to what? H plus A comma K, right? But we know the focus S, which is minus 3 comma 3 by 2. Here A equal to 1 by 4, so we should have H plus 1 by 4 equal to minus 3. That means H equal to minus 3 minus 1 by 4. That should give you H equal to minus 13 by 4. Okay, obviously K equal to 3 by 2. Now we got H comma K equal to minus 13 by 4 comma 3 by 2 and A equal to 1 by 4. Therefore, the equation of the parabola is going to be this: y minus 3 by 2 whole square equal to 4 times 1 by 4 x minus of minus 13 by 4. Yes, okay. So if you simplify, you will get 2y minus 3 whole square equal to, this 4 cancel, 4x plus 13. Okay, so this is this blue parabola which is open right side. Okay, similarly, now if you want to find out the parabola which is open left side, here if this is a h comma k, if A equal to h comma k in that case, then the focus should be what? H minus A comma K, which is given as minus 3 comma 3 by 2. In this case, H minus 1 by 4 equal to minus 3 implies H equal to minus 3 plus 1 by 4, which should be minus 11 by 4, and again K equal to same 3 by 2. So in this case, the equation of the parabola is going to be, so now I can write down equation of the parabola is going to be y minus 3 by 2 whole square equal to minus 4 times 1 by 4 times x minus of minus 11 by 4, it's going to be x plus 11 by 4. Okay, so this gets simplified to 2y minus 3 whole square equal to minus 4x minus 11. Okay, I can write minus of 4x plus 11. Okay, so this is the red parabola which is open left side. Okay, fine. Next, problem 10 from section 1 of the exercise 3a. If 1 by 2 comma 2 is one extremity of a focal chord of the parabola y square equal to 8x, then find the coordinates of the other extremity. First of all, let me draw a rough graph of this parabola y square equal to 8x, whose axis is x-axis actually, vertex at 0, 0. If you compare this y square equal to 8x with a standard equation y square equal to 4ax, you will see that 4a equal to 8, that implies a equal to 2. So the focus will be at 2 comma 0. Okay, this is the focus. Now one of the extremity of the focal chord is 1 by 2 comma 2. So here it will be, this is the rough location of 1 by 2 comma 2. Let me call it P. Okay, so the focal chord is what? Chord passing through focus. So other extremity will be roughly here, P dash. We want this other extremity. Okay, okay, fine. As I know 2 points on this chord, I can get this chord equation, okay, which is a line passing through P and S, okay, whose slope will be what? Actually 2 minus 0 by 1 by 2 minus 2, which is going to be minus 4 by 3. So the PS equation will be line passing through 2 comma 0. So y minus 0 equal to, with a slope minus 4 by 3, minus 4 by 3 times x minus 2. Okay, so y equal to minus 4 by 3 times x minus 2. So this is this PS equation. Fine. Okay, now I'm going to get this P dash as the intersection point of this parabola y square equal to 8x and the straight line y equal to minus 4 by 3 times x minus 2. Actually, there are 2 points of intersections P and P dash, but P we already know. We just have to see what is the other point, that is P dash. That's what we are interested in as the other extremity of this focal chord P dash. Fine. Okay. Now let us solve these two equations, y square equal to 8x and y equal to minus 4 by 3 times x minus 2 simultaneously. What we do, simply substitute this y in the first equation. So minus 4 by 3 times x minus 2 whole square equal to 8x. So 16 by 9 x minus 2 whole square equal to 8x. So the 16, 8 will have a 2 here. So 2 times x square plus 4 minus 4x equal to 9x. So we have a 2x square plus 8 minus 8x equal to 9x. This I can write 2x square minus 17x plus 8 equal to 0. This is a quadratic equation, so we can solve for x here. So the 17x I can write 16x minus 6 plus 8 equal to 0. So this is going to be 2x x minus 8 minus 1 of x minus 8 equal to 0. So we will get 2x minus 1 times x minus 8 equal to 0. That implies x equal to 1 by 2, x equal to 8. So for x equal to 1 by 2, we get this point. Now let us focus on this x equal to 8. For x equal to 8, what will be y value? Again, if you plug in this line equation, y equal to minus 4 by 3 times 8 minus 2. So it's going to be minus 4 by 3 times 6. It's going to be minus 8. So this p dash point going to be 8 comma minus 8. So other extremity of this focal chord is going to be 8 comma minus 8. Fine. Next, problem 11 from section 1 of the exercise 3a. Prove that the point on the parabola y square equal to 4ax that is nearest to the focus is its vertex. Here a positive. Let me draw a rough graph for the parabola y square equal to 4ax, whose axis is x-axis. Okay, so whose focus is s a comma 0. The vertex is 0 comma 0. As you can see, vertex 0 0 is point on the parabola. Fine. Here we have to show the vertex A is the nearest point to the focus on the parabola. That means if you take any point P other than this vertex on the parabola, then we have to show that SP greater than SA. Okay, distance from this focus to that P should be bigger than distance from that focus to the vertex A. Okay, fine. Okay, let Px1 y1 is different from the vertex 0 0. That means x1 must be positive because we have a graph only positive side of x-axis. So for any point on the parabola, the x coordinate must be positive. Fine. Now let us look at SP. SP is going to be what? It's actually focal distance of the point P. Focal distance of the point P, which is x1, y1. We already know from lecture 58, the focal distance of the point going to be x1 plus a, right? Okay. Now x1 plus a is bigger than a, right? Since x1 positive. So what is a? Actually distance from this vertex to focus is actually a. Okay. So I can say that now SP is bigger than SA. Fine. Therefore, we can say the vertex A is nearest to focus S on the parabola y square equal to 4ax. Okay, fine. Next, problem 12 from section 1 of the exercise 3a. A comet moves in a parabolic orbit with the sun as focus. When the comet is at 2 times 10 to the power of 7 kilometers from the sun, the line from the sun to it makes an angle pi by 2 with the axis of the orbit. Find how near the comet comes to the sun. Okay, here comet moves in a parabolic orbit with the sun as a focus. Let me draw a parabola whose equation y square equal to 4ax and whose axis will be x-axis. Here the sun is at the focus, yes. Okay. Now comet moves on this parabola. Fine. When comet is here at this location, say L, so that this line segment LS will make an angle pi by 2 with the axis of the parabola. Then it is given that this distance LS equal to 2 times 10 to the power of 7. Okay, fine. If you extend this LS so that it meets the other part of the parabola at L dash, then we can say that this L dash segment is lattice rectum because it is a double ordinate passing through the focus. So we can say this is a lattice rectum. So the length of the lattice rectum is, we know that 4a. Okay, if L dash equal to 4a, then SL must be equal to half of that, that must be 2a. Okay, so this 2 times 10 to the power of 7 must be equal to 2a. That implies a must be equal to 10 to the power of 7. Okay, from the previous problem we can say that the comet will be nearest to the focus, that is sun, when comet is at the vertex A. Here this is the vertex A. So when comet is here, the comet will be nearest to the sun and the distance is going to be equal to a, that is the distance from vertex to the focus. Okay, and that a we got 10 to the power of 7. So answer is 10 to the power of 7. Problem 1 from section 2 of the exercise 3a. Find the locus of the point of trisection of double ordinate of a parabola y square equal to 4ax a positive. Okay, let me draw this parabola y square equal to 4ax. Okay, whose axis is x-axis. Okay, for any x positive, okay, we have a double ordinate p dash. Let us say this is p dash. This is a point x comma 0 on x-axis. The p coordinate is going to be x comma 2 root ax, and p dash coordinate going to be mirror image of p, that's going to be x comma minus 2 root ax. Okay, so this is the double ordinate. For any x positive we have a double ordinate p dash whose coordinates are x comma 2 root ax, p dash is x comma minus 2 root ax. Okay, now we are looking for locus of point of trisection of double ordinate. We are looking for a point, say x1, y1, which divides the point p dash in 1:2 ratio. Okay, let x1 comma y1 be point on p dash which divides p dash in 1:2 ratio. Okay, that's what we mean by trisecting. Okay, trisecting p dash. Okay, then this x1 y1 must be what? Point which divide this p dash in 1:2 ratio, means we should have x plus 2x by 3 comma minus 2 root ax plus 2 times 2 root ax by 3, which is going to be x comma 2 root ax by 3. Okay, that is the x1 y1. You can see here x1 equal to x and y1 equal to 2 root ax by 3. Okay, so that implies y1 equal to 2 root ax1 by 3. Okay, so we have 3y1 equal to 2 root ax1. If you take a square both sides, 9y1 square equal to 4ax1. Okay, therefore the locus of point of trisection of double ordinate is going to be 9y square equal to 4ax, which is again parabola. Fine. Okay. Next, problem 1 from section 3 of the exercise 3a. Find the equation of the parabola whose focus is point minus 2 comma 3 and directrix is the line 2x plus 3y minus 4 equal to 0, and also find the length of the lattice rectum and equation of the axis of the parabola. First of all, the line passing through the focus and perpendicular to the directrix will be the axis, right? So this is the line, okay, this is the axis. As you can see, this axis is neither parallel to x-axis nor parallel to y-axis. So we are going to have a general equation of the parabola. Okay, we know how to write down general equation of the parabola in terms of focus and directrix. Here focus and directrix both are given. Here the focus S alpha beta is actually minus 2 comma 3, and the directrix Lx plus my plus n equal to 0, actually 2x plus 3y minus 4 equal to 0. So the general equation of the parabola with a focus alpha beta and directrix Lx plus my plus n equal to 0 is this: x minus alpha whole square plus y minus beta whole square equal to Lx plus my plus n whole square by L square plus m square. Okay, so here alpha equal to minus 2, beta equal to 3, L equal to 2, m equal to 3, n equal to minus 4. So I can write down x plus 2 whole square plus y minus 3 whole square equal to 2x plus 3y minus 4 whole square by 2 square plus 3 square. Okay, you can simplify this further to get general second degree equation in x and y, but I am stopping here. Feel free to simplify this. Okay, next, also find the length of the lattice rectum. Okay, the length of the lattice rectum equal to 4a, right? We know that length of the lattice rectum is actually 4a. But what is a here? Okay, now the intersection of this axis and directrix, let us denote by z. The focus is S. Now I can say that this SZ will be equal to 2a, because here is the vertex A. The vertex going to be midpoint of this Z and S, and we know that distance between A and S will be equal to A. That's why this SZ must be equal to 2a. What is SZ here? The perpendicular distance from focus to directrix. Okay, so SZ will be equal to mod 2 times minus 2 plus 3 times 3 minus 4 by under root 2 square plus 3 square. It's going to be 1 by root 13. So what is SZ here? 2a equal to 1 by root 13. So what will be 4a? It will be 2 by root 13. So therefore the length of the lattice rectum equal to 2 by root 13. Okay, fine. Next we have to find equation of the axis. Okay, so what is the axis? It is a line passing through the focus and perpendicular to the directrix. Okay, if the focus is minus 2 comma 3, so first of all the slope of the directrix I can write is going to be minus 2 by 3. So the slope of the axis must be equal to what? 3 by 2. So now line passing through the focus minus 2 comma 3 and having the slope 3 by 2. So that is going to be the axis. So axis equation going to be y minus 3 equal to 3 by 2 times x plus 2. It's going to be 2y minus 6 equal to 3x plus 6. It's going to be 3x minus 2y plus 12 equal to 0. So this is the axis of the parabola. Okay, so this equation is 3x minus 2y plus 12 equal to 0. Okay, fine. Next, problem 2 from section 3 of the exercise 3a. Prove that the area of the triangle inscribed in the parabola y square equal to 4ax is 1 by 88 times modulus of y1 minus y2 times y2 minus y3 times y3 minus y1 square units, where y1, y2, y3 are the ordinates of its vertices. Okay, first let me draw the parabola whose equation is y square equal to 4ax. Okay, here no 3 points on the parabola will be collinear. So if you take any 3 points on the parabola, they will make a triangle for sure. So let me say this point is A, whose coordinates are x1, y1. Let me say this is B, whose coordinates are x2, y2. This is C, whose coordinates are x3, y3. Okay, so these 3 points will make a triangle for sure, which will be inscribed inside the parabola. Okay, okay, fine. Now let x1, y1, x2, y2 and x3, y3 are points on the parabola y square equal to 4ax. Okay, that means since x1, y1 is a point on the parabola y square equal to 4ax, we must have y1 square equal to 4ax1. That implies x1 must be equal to y1 square by 4a. Similarly, we should have x2 equal to y2 square by 4a, x3 equal to y3 square by 4a. Okay, fine. Now we want to prove that area of this triangle ABC equal to 1 by 88 times modulus of y1 minus y2 times y2 minus y3 times y3 minus y1. Okay, we know what should be the area of the triangle in terms of 3 vertices x1, y1, x2, y2, x3, y3, right? So I can write this area of triangle ABC in terms of these 3 vertices should be 1 by 2 times x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay, fine. Now let us replace x1 with a y1 square by 4a, x2 with a y2 square by 4a, x3 with a y3 square by 4a. Here you will have x1 I am replacing with y1 square by 4a, then we have y2 minus y3 plus x2 I am replacing with y2 square by 4a, then we have y3 minus y1 plus x3 I am replacing with y3 square by 4a, then we have y1 minus y2. Okay, now if we get the 4a in the denominator out, so we can write 1 by 88 times y1 square times y2 minus y3 plus y2 square times y3 minus y1 plus y3 square times y1 minus y2. Okay, fine. Now let us add and subtract y2 square times y2 minus y3. Okay, here let me subtract y2 square times y2 minus y3, and here let me add y2 square times y2 minus y3. Okay, fine. Now 1 by 88 times. Okay, so from here if I take y2 minus y3 common, then we will have y1 square minus y2 square. Okay, then from here if I take y2 square common, then I will have y3 minus y1 plus y2 minus y3. Okay, as you can see, these two cancel. Then we have y3 square times y1 minus y2. Okay, fine. 1 by 8a. Here y2 minus y3 times this y1 square minus y2 square, I can write y1 minus y2 times y1 plus y2. Okay, now here if I take y2, now if I take y1 minus y2 common from these two things, so I will have here y3 square minus y2 square. Okay, again 1 by 88 times. Okay, again this thing we can write y3 minus y2 times y3 plus y2. Okay, so if I take y2 minus y3 times y1 minus y2 common, okay, then we have y1 plus y2. Okay, so here y1 minus y2 got out, and we have taken y2 minus y3 out, but here we have y3 minus y2, so we should get a minus here, minus the leftover thing is y3 plus y2. Okay, again this y2 get cancelled, so then we are left with a 1 by 88 times modulus of this y1 minus y2 times then y2 minus y3 times. Here we have y1 minus y3, but I can also write like a y3 minus y1 because anyway we have modulus, no problem. Okay, so this is the area of the triangle which is inscribed inside the parabola y square equal to 4ax, where y1, y2, y3 are ordinates of its vertices. Okay, fine. Now we are going to see equation of a tangent and normal at a point on the parabola. Okay, first let us try to understand points of intersections of the parabola with a given line. Okay, here let me consider the parabola y square equal to 4ax, a positive, and the line y equal to mx plus c, m not equal to 0. Okay, here let me name the parabola equation as a 1 and the line equation as a 2. Okay, now we have to solve 1 and 2 for points of intersection. Okay, so what we do, we simply take the y equal to mx plus c from 2 and substitute in the 1, then we will end up with the expression like this. Okay, so if you expand left hand side, you will have m square x square plus c square plus 2mcx equal to 4ax. If you take the 4ax other side, then you will end up with a quadratic equation x. Okay. Here A, M, C are known, here X is unknown, so which is a quadratic equation in X which will have two roots x1 and x2. Okay. Here there are three cases. Case 1. Here x1, x2 may be real and distinct. In that case, for each of x1, x2, you can get the corresponding y values from the equation 2. Then you will have two points of intersections x1, y1, x2, y2 like this. In that case, the line will be cutting the parabola at 2 points P and Q. Here P is x1, y1, Q is x2, y2. Okay, fine. Case 2. x1, x2 real and equal. Okay, this quadratic equation having real and equal roots. In that case, we have only one x1, then we can get the corresponding y1 value from this equation 2. Simply plugging x1 value here, you get the y1 value. In this case, we have only one point of intersection, so the line will be touching the parabola like this. Okay, here the x1, y1 is the point of intersection. We have only one here. Okay, fine. Okay, next. Case 3, x1, x2 imaginary. That means non-real roots. In that case, we do not have any points of intersection. So, the line and the parabola look something like this. Okay, they do not have any points of intersection. Okay, we are mainly interested in this case. Here, when x1, x2 are real and equal, we have only one point of intersection. In this case, this line is tangent to the parabola y square equal to 4ax at a point x1, y1. Here this point x1, y1 is called point of contact. Now question is, what should be the condition on the line so that the line y equal to mx plus c will be a tangent to the parabola y square equal to 4ax. We have seen that when we have a real and equal roots for this quadratic equation 3, then this line will be a tangent. Okay, so we know that we will have a real and equal roots when the discriminant is 0. Okay, if you have a quadratic equation like ax square plus bx plus c, okay, then what will be the discriminant? Delta equal to b square minus 4ac. Here our a going to be m square. This 2 times mc minus 2a going to be b. The c square going to be c. Okay, so what will be our discriminant? 4 mc minus 2a whole square minus 4 m square c square. This should be 0. Then we can have real and equal roots. Okay, now let us see what is this 4. If I expand mc minus 2a whole square, I will have m square c square plus 4a square minus 4mca minus 4m square c square equal to 0. Okay, so if you multiply 4m square c square plus 16a square minus 16mca minus 4m square c square equal to 0. As you can see, this one cancel. Now if I take a 16a common, then we have a minus mc equal to 0. So a is positive, a not 0, so a must be equal to mc. So this is the condition, or else we can say c must be equal to a by m. So if this c equal to a by m, then this line y equal to mx plus c will be a tangent to this parabola y square equal to 4ax. And what will be that point of contact? First of all, what is x1? x1 is a real and equal root. So when this is 0, the real and equal root going to be what? Minus b by 2a, right? So minus b by 2a. So in this case, so what should be that x1? Minus b minus 2 times mc minus 2a by 2m square. Okay. So this 2 to cancel. Now MC equal to A, right? If it is a tangent, then MC equal to A. So I can write this one minus of A minus 2A by M square. It's going to be A by M square. So x1 is going to be A by M square. Then what will be y1? So if you plug it here, M times A by M square plus C. What is C should be? C should be A by M. A by M. Okay. So this should be A by M plus A by M. That's going to be 2A by M. So this point of contact going to be A by M square comma 2A by M. Okay. When C equal to A by M, this line y equal to mx plus c will be a tangent to the parabola y square equal to 4ax, and the point of contact going to be A by M square comma 2A by M. Fine? Okay. Now let me state the theorem. The condition for a straight line y equal to mx plus c, m not equal 0, to be a tangent to the parabola y square equal to 4ax is cm equal to a. Okay, that is c must be equal to a by m. Fine, we have seen this. Okay, note, when m equal to 0, the line will be y equal to c. The y equal to c, the line parallel to axis of the parabola, because y equal to c, the line parallel to x-axis, and the axis of the parabola y square equal to 4ax is x-axis. So that's why the y equal to c will be a line parallel to axis of the parabola, which is going to cut the parabola at one point like this. Okay. So the point of intersection going to be c square by 4a comma c. Simply your y equal to c, right? If you plug in y equal to c here, you get a c square equal to 4ax. That implies x will be equal to c square by 4a. That's why the point is c square by 4a comma c. This is the point of intersection. Okay. Y equal to c line going to cut the parabola at a single point, but it is not a tangent. Okay. Fine. Next, for m not equal to 0, the line y equal to mx plus a by m is always tangent to the parabola y square equal to 4ax at a by m square to a by m. From the theorem, we can say that when c equal to a by m, the y equal to mx plus c will be a tangent. So that's why y equal to mx plus a by m should be always tangent to the parabola y square equal to 4ax. And we have already seen the point of contact is what? A by m square comma 2a by m. Okay, fine. For m not equal to 0, the y equal to mx intersect the parabola y square equal to 4ax at 2 points 0, 0 and 4a by m square comma 4a by m. As you can see, here what you do, simply substitute y equal to mx in the parabola equation y square equal to 4ax. You will get mx whole square equal to 4ax. This we can write m square x square minus 4ax equal to 0. If you take x common, m square x minus 4a equal to 0. That means x equal to 0 or m square x minus 4a equal to 0. That implies x equal to 4a by m square. Okay. If x equal to 0, then if you plug in x equal to 0 in this line y equal to mx, you will get a y equal to m times 0. That implies 0. So one point of intersection is 0, 0. So we have a 0, 0. If x equal to 4a by m square, then y equal to m times 4a by m square, it's going to be equal to 4a by m. So other point of intersection is 4a by m square comma 4a by m. So in this case, the line y equal to mx intersect at 2 points. One is at origin, Other is at 4a by m square, 4a by m. Fine. Okay. For y square equal to 4ax, there is only one tangent parallel to y-axis, that is y-axis itself. See, for the parabola y square equal to 4ax, okay, so at a vertex, the tangent is y-axis, right? Okay, this is the only tangent that is parallel to y-axis. So y-axis is tangent to the parabola at the vertex 0, 0. Fine. Okay. There is no tangent parallel to x-axis, because if you take any line parallel to x-axis, that's going to cut the parabola at single point like this. Okay. Okay. For any m not equal to 0, the line x plus my minus 2a minus a by m square equal to 0 is always normal to the parabola y square equal to 4ax at a by m square comma 2a by m. Okay, first of all, we know that y equal to mx plus a by m is always tangent for any m not equal 0 is tangent to the parabola y square equal to 4ax at the point of contact, that is a by m square comma 2a by m. Okay, fine. Now what is the normal? Normal at this point a by m square comma 2a by m going to be line passing through this point a by m square comma 2a by m and perpendicular to the tangent. Okay, so slope of the normal going to be what? Slope of normal should be equal to minus 1 by slope of tangent. Okay. What is slope of tangent? That is m. So which is minus 1 by m. Now let us write down the line equation which is passing through a by m square comma 2a by m and having the slope minus 1 by m. Which is going to be y minus 2a by m minus 1 by m times x minus a by m square. Okay, this one I can write my minus 2a by m equal to minus 1 by m square x minus a by m square. Okay, now if I cancel these things, so if I bring m square this side, then I will have m cube y minus 2a m square equal to minus m square x plus a. If I bring everything one side, then I will have m square x plus m cube y minus 2a m square minus a equal to 0. If I take m square common, then x plus my minus 2a minus a by m square equal to 0. Since here m not equal to 0, we must have x plus my minus 2a minus a by m square equal to 0, since m is non-zero. Okay, so this is the normal to the parabola y square equal to 4ax at a by m square comma 2a by m. Okay, so for any m not equal to 0, this line x plus my minus 2a minus a by m square equal to 0 is always normal to the parabola y square equal to 4ax at a by m square comma 2a by m. Okay. Okay. Next theorem statement. Two tangents can be drawn from an external point x1, y1 to the parabola y square equal to 4ax. Let's say this is a parabola y square equal to 4ax. If you take any external point x1, y1, point which is exterior to the parabola, then you can always draw two tangents from this point. Okay, like this roughly. Okay, so we have to prove this. Okay, first of all, here x1 y1 is exterior to y square equal to 4ax. Okay, so then that implies we can say s11, that is y1 square minus 4ax1 is positive, right? If x1 y1 is exterior to the parabola y square equal to 4ax, then s11 is positive, that is y1 square minus 4ax1 positive. Okay, fine. And we know that any tangent to the parabola y square equal to 4ax will be in the form y equal to mx plus a by m for some m not equal to 0. Okay, so this is how tangent equation look like for some choice of m. Okay, now let us see for what choice of m these lines are passing through x1 y1. Okay, this tangent must pass through x1 y1, so we must have y1 equal to mx1 plus a by m. Okay, now if you cross multiply, then you will have m y1 equal to m square x1 plus a. Okay, again if you bring one side, then I can write x1 m square minus y1 m plus a equal to 0. Okay, so this is the relation we have here. X1 y1 a are known, so this is going to be a quadratic equation in m. Quadratic equation in m. Okay, so okay, now let us look at the discriminant for this quadratic equation. Okay, so this x1 is like a, this minus y1 like a b, this a like a c. If you compare with a quadratic equation like am square plus bm plus c, quadratic equation in m. Okay, fine. The discriminant delta is going to be what? B square minus 4ac means here minus y1 whole square minus 4x1 a. Okay, so we got y1 square minus 4ax1, which is equal to s11. We know this is positive. Here discriminant positive, so this quadratic equation m will have two distinct real roots. Will have two distinct real roots. Two real roots, say m1, m2. Here m1 is not equal to m2. So for m1 we have a one tangent which is passing through x1 y1, and for m2 there is another tangent which is passing through x1 y1. So we have two tangents from x1 y1 to the parabola y square equal to 4ax. One is y equal to m1x plus a by m1. Another one is y equal to m2x plus a by m2. Okay, so this is a 1, this is a 1. Okay, there are two tangents from x1 y1 to the parabola y square equal to 4ax, always, as long as the point x1 y1 is exterior to parabola. Fine. Okay, let me stop here. I'll continue in the next class. Okay, thank you.